Hello and welcome to 24 Hours of PASS Summit Preview. We're really excited you can all join us today for Carlos Bossy's session on predictive analytics in the enterprise. This 24 Hours of PASS event consists of 24 consecutive live webcasts. The sessions will all be recorded and posted online soon after the event. My name's Martin Kearney. I'm a consultant with LobsterPot Solutions based in Melbourne in Australia. I also run the local SQL Saturday event here in Melbourne and a monthly SQL Server based meetup group based more on the opportunity to network with other SQL Server professionals rather than the traditional technical sessions. I've worked with SQL Server for almost 15 years, both here in Australia and in the UK. And I have a few quick introduction slides before I hand over the reins to Carlos. He'll then speak to you for 40 to 45 minutes. And then we'll move on to the Q&A where you can ask any questions you may have from the session. Next slide, please, Carlos. If you're having any issues during the session, please type the issues into the question pane and somebody will try to assist you with the issue. To maximize your screen, there's a zoom button located at the top of the presentation window. Feel free to enter your questions in the Q&A field at any time. The questions pane is located to the right-hand side of your screen. Once we get to the Q&A portion of the session, I'll read off your questions to the speaker and hopefully we get them all answered there. Note there will also be a short evaluation at the end of the session and your feedback is important to us, so please take a moment to complete it and it will show up on your screen at the end of the event. Next slide, please. So I'd like to take a moment also to thank our event partners. The staging of 24 Hours of PASS wouldn't be possible without their support and dedication. They're the reason that this event is available free of charge to you all. Thank you to our presenting sponsors, Microsoft and Dell Software. Next, as you all may know, this 24 Hours of PASS is a preview of the PASS Summit 2014, the largest conference for SQL Server and BI professionals. With over 5,000 attendees representing 2,000 companies from 52 countries, Summit is a time to share, connect and learn with your peers and industry partners. PASS Summit is not only a week of intensive learning and knowledge sharing that will offer strategic insights, it's a time to network and rub shoulders with industry experts. Taking place in Seattle, Washington from November the 4th to the 7th, PASS Summit will feature over 190 world-class sessions across 5 topic tracks. These 24 hours of PASS sessions provide a mere glimpse of what you can expect from PASS Summit. Find out more at www.passsummit.com, and if you register by September the 26th using the discount code 24HOP14, you'll get $200 off the registration fee. And now, please allow me to present the speaker of the hour, Carlos Bossy. Carlos is a data and BI architect with over 25 years of experience in software and database development and is a principal consultant for Quanta Intelligence. He's developed warehouse and BI solutions for a variety of industries and state agencies and focuses on developing BI solutions. So I'll now pass over on to Carlos to present this session.
Okay, well, thank you very much, Martin. I appreciate the introduction, and thank you for hosting. As Martin said, the title of my session is Predictive Analytics in the Enterprise, and this is a preview session of a session I'll be doing at it's a pre-con, actually, that I'll be doing at the PASS Summit this year in November. So if you're interested in this session and it sparks your interest, make sure you try to attend the pre-con as well, as we'll get a full day of predictive analytics at the PASS Summit. Martin already talked about who I am. I basically been working for about the last 10 years as a BI consultant for my own company, mostly in the data warehousing, data mining space, data integration. I've spoken at the PASS Summit for the last 3 years, so this will be my fourth time. I'm also on, I participate in several users groups, and I'm on the virtual chapter, past performance virtual chapter board, and I'm also on the board of TTWI in Colorado. So I participate quite a bit in several groups. The agenda here, and this is a shorter session, so we probably won't be able to get through everything, but we'll talk a little about data science. And data science is basically the umbrella under which predictive analytics falls under. We'll talk about predictive modeling and do an overview of what that is. We'll also talk about how you can do data mining with Excel, and maybe review a case study a real case study of something I've worked on in the past. We'll walk through what building a predictive model is and how we go about it. Talk about the tools and the algorithms. And then one of the exciting new things that we'll talk about today is the Azure machine learning predictive model development tools, and I'll also demo some of that. So, today we have analysis services that provides us with data mining tools and predictive modeling tools, and now with Azure, there's the Azure ML as a new preview edition where we can do some predictive modeling as well. So I'll kind of show both. Most people probably own analysis services, so they can do data mining today using analysis services. And then we'll talk about, but we'll also talk about the new stuff that's coming up because it's pretty exciting. And then we'll also talk about how to use the models. So this is an overview of the pre-con and the agenda I have at the pre-con. So just to show you, it goes into a lot of detail on how we build models, use models. There's exercises, there's hands-on stuff. People, if they go to the pre-con, will be able to follow along and do the exercises themselves. I'll provide the data, and so we can all work together, and so you can leave that session having actually done real work building predictive models. So data science, what is data science? And basically data science uses a lot of different disciplines: math, statistics, data warehousing, advanced computing, visualization, to learn about data, to understand the data better, to get meaning out of the data. And for us, what it really means is we're going to build models that allow us to make predictions with the data. So from our point of view, that's the purpose of this session. That's the purpose of my pre-con, is how do you build a model that you can implement in a production environment that makes predictions in various places like web pages and reports and integration, ETL, integration services, that sort of thing. It's basically a new term that you hear thrown about a lot. Maybe we used to call it competitive intelligence or business analytics, but data science is basically the novel term that covers this broad area that's really taking off these days. So what is predictive modeling? Well, basically it's the process by which a model is created to best predict the probability of an outcome. So in the end, what I have is a model that best guesses the outcome using a given set of input data. So predictive analytics is really the process of building predictive models. My definition of it is that it's the discovery of predictive information. Sometimes that information is hidden from databases. Sometimes those databases are large. They don't always have to be large. I mean, we can do predictive modeling with small data, but often we can get better results or more sophisticated results with larger data. We can use related and unrelated data attributes. Data that's in a relational database, data that's in a data warehouse, but maybe data that's somewhere else too. In Excel spreadsheets, it's maybe offsite, it's external to us. But we can bring it in and help us with building the models. And we do algorithmic analysis. We apply algorithms to the data, and those algorithms create models that then allow us to generate predictive results. So essentially that's what we're going to do here. You're going to see a few demos and see how I do it, and some simple things that you can do so you can get started doing this yourself too. So this is kind of an older slide that I kept in here, but it's really talking about what tools do people use. And the reason I put it in here is because you can see that it's a little bit all over the place. I think this is a fairly, I wouldn't say it's a new discipline, but it's a discipline that's really got a lot of excitement and people thinking about it in the last year or two. And so people are using a lot of different tools. There's a lot of ways to do this. I know, like R, for example, has gotten a lot of press and a lot of attention as one of the tools to use this. So R is a programming language that you can do statistical analysis with and predictive modeling with and data mining with. But there's a lot of other tools you can use, and you can see that a lot of people say they use Excel, and a lot of people say they use multiple tools because these numbers don't add up to 100%. And now Microsoft is introducing a new tool that isn't on this list, so there's a lot of competition in this area, and I think hopefully I'll show you some of the ways that maybe in the SQL Server community you have certain options to go with as far as tools on the tool side. So what does Microsoft provide? Well, Microsoft has provided analysis services and the data mining algorithms and analysis services for several years now. I mean, I think going back to 2005 at least it was there. So for at least 10 years, people have been able to build predictive models with analysis services. And the way you could do this with SQL Server data tools, or you could do it with Excel. So with Visual Studio you could build predictive models. You could also build them with Excel, but essentially you were using the same engine under the covers. And now there's Azure Machine Learning, which is another way to do it. And I think it's the way of the future that Microsoft is providing in this space as their way of competing with tools like R and RapidMiner and that sort of thing. So what do we want to achieve? Well, really the end result is we want to be able to take data, build a model, and have that model make predictions, and then take that model and deploy it into our enterprise, embed it in our tools, embed it in our reports, and really have the model be available at a massive scale so the decision making that the model provides can benefit everybody within an organization. It can be in a web page and make predictions thousands of times a day, or in a report and make predictions every time the report runs. So we want those models to be available to everybody, so that way we can improve the decision-making abilities of anybody in our organization. The other thing we might want to achieve is understanding our data. So often what we want to do is first when we do some data mining is we just want to understand our data better. We want to build clusters of the data. We want to see how many clusters we can build, what type of data goes into what type of cluster, what's similar, what type of data is, for example, what type of customer is similar to other customers, what type of customer is different from other customers. So often we want to also achieve that, and often that achievement is really just ultimately a better understanding of the data, but it's also a valid part of the process. So predictive analytics is essentially a component of a BI data architecture. I know a lot of BI architectures probably don't include it today, but in the future I think most BI architectures will. Our typical BI systems have measured the past. We've always said let's trend how our organization is doing, how are our sales doing, how are our customers doing, how are our employees performing. And we've always been about measuring the past. So with predictive analytics, we also can include how predictions about the future and trending about the future and things like that. And one of the things that I like to point out is the ROI can be very high on some of these projects. When a project incorporates predictive analytics as part of its BI project, the ROI can increase more than 50%. So. And I've seen that firsthand in my experiences. Predictive analytics projects can do very, very well. They can be very hard to sell to management, but if you understand that you can get a high rate of return with the project, then it's an easier sell to management. So what are the kind of things we do? Well, I'm going to go through this case study that I worked on how to predict workers' compensation claims. And so basically workers' compensation in the United States, the way it works is somebody is working on the job and they get injured, they get hurt, and so they put in a claim, a medical claim, and the medical claim gets processed and paid for by the workers' compensation insurance. And so the company I did this work for, they basically processed workers' compensation claims for larger organizations that had a lot of employees that did the type of work that they could get injured or hurt in. And so they had a lot of history, a lot of data. That was good, because one of the things we can't do is we can't do good predictive analytics without historical data. We need some kind of basis for building the models. They had a lot of cases that they had processed and closed, so they knew the end result of those cases. For example, somebody came in, hurt their back, were treated at the doctor, and the cost of the treatment was $600. And the case was closed. So to them, that was a claim that they could track, and they knew the various pieces of the claim, what the injury was, who the worker was, and then they knew the cost of the claim. So what they wanted to do is predict how many claims were high cost, would be high cost. And to them, a claim would be high cost if it was over $2,500. If it was over $2,500, that's a high cost claim. And only 1 out of 20 of the cases were high cost claims. And they understood that some claims could be managed better and the cost could be reduced, and that the employee who was hurt could be treated better if they knew that a claim was going to be a high cost claim. And so what we did is we built predictive models based on the information about the claim, who the employee was, their age, their gender, how long they had worked at the company, what type of job they did, what type of injury they reported, and what body part they injured. And based on those variables, we predicted how expensive that claim would turn out to be. And we were fairly successful. We were about 85% successful in identifying high-cost cases, which was very good. I mean, it was they had a higher target, but they wanted to be more successful than that. Or I'm sorry, we weren't 85. Their target was that they wanted to be 85% successful. And so what we did is we initially built a model, and we were successful 79% of the time. So we actually were a little bit under their target initially. And what they did is they used those models in the reporting system. Every time they ran reports on claims, they also predicted that whether the claim would be a high-cost claim, and they predicted the probability of that claim being a high-cost claim. And we used a neural network algorithm for that. But then we subsequently developed a more sophisticated algorithm or a model here. We balanced the data and trained the data differently. And what we did, balancing the data means we actually oversampled the data. The data heavily had non-high-cost claims and very few high-cost claims, and a lot more claims that were not high-cost. So what we did is we actually balanced it, so we had a little bit better representation in data of what a high-cost claim looked like. And then what we did is we built 3 models. A model at the time the claim was reported, a model at the time the employee saw a doctor, and a model at the time the employee got a medical prescription. And then what we did is we predicted 3 things: the cost of the claim, the cost of the prescription drugs, and the duration of the claim. And using this technique, basically 9 different models, 3 different models, 3 different ways, we were able then to improve on the success rate by predicting 90% of the time correctly when a claim would be a high-cost claim. So that's kind of the general, I know this is kind of quick that I'm going through this, but that's basically the general process of going through and building a predictive model and trying to achieve a high rate of accurate predictions. The rate that you're looking for can be very different in your own, in your own project, your own organization. But basically what they did is every time a claim was updated, any new information came in, so they changed the claim. then the claim would be scored again. We would then say, is the claim going to be a high-cost claim now because we got new information? And then we always store the results of our prediction, so we know how we're doing. We know how well our models are actually predicting. Are we successfully predicting or not? So that's generally the how a project would work. So what can we do? What can we use to build these predictions? Well, one of the things we can use is SQL Server analysis services and Excel or BI Studio SQL Server data tools to do this. So any SQL Server version, I think between 2005 and 2014, using analysis services multidimensional, has these algorithms. Now, there are 9 algorithms we can use, but it doesn't have a lot of algorithms. There's random forest. It doesn't include support vector machines. It doesn't have. There's a lot more we don't have. So a lot of people, when they do this, they use like tools like R and Python and RapidMiner and things like that. So the tools that we have in analysis services are good and they're valuable, and we've done some good work with those tools. But again, it was kind of limited in what they could do, and some of the other tools out there on the market had a lot more. So now we also have the Azure ML algorithms, the Azure machine learning algorithms, and there's a number of new algorithms here. And again, this is just preview mode, so maybe when this goes live, comes out of preview mode, maybe there's going to be more algorithms. But basically, we get a lot more choices. And we get more things that we can do. There's certainly algorithms here that we don't have in analysis services, and there's more options for us to use. So I'm going to later on demo that as well. But before we go on to the demos, I just want to talk quickly about the methodology, the general methodology here that we will implement in a predictive analytics project. One of the things we'll do is we'll gather data, and that's really one of the big important things. Get data that's related to what we want to predict, and get as much of it as we can, as much good, clean data that we can. We need to explore that data, understand that data, and then we need to prepare that data. Often the data as is isn't necessarily what we want to build the models. We need to discretize the data. We need to sample the data. We need to filter the data. There's things we need to do to it often before we actually can build the models. And then what we do, once we have good data, we separate the data. Usually there's a training data set, a testing data set. We choose the algorithms. We train the models using the algorithms, using the training data set. And then we test what we did using the testing data set. And that tells us, are the models that we built, are they good or not? Are they models that can actually help us make good predictions, better predictions that we can make otherwise? And once we go through that cycle, we find models, we build models that are good, and we ultimately can prove that they will execute well in production. Then we can deploy them to a production environment so they can be used in reports and other places. And then what we need to do is monitor those models, make sure they continue to work well, because if they models can sometimes predict well for a while, but they don't predict well forever. So we need to make sure that our predictions are still as good as they've always been before. Otherwise, we may need to rebuild the models, or we may need to start over. So one of the things that I want to make the point here is that most of the work here is in this data gathering process. Probably 60 to 80% of the work is in gathering, exploring, and preparing the data. That's where in these projects you'll find you'll spend a lot of your time if you go down this path. And if you spend the time there, it's very valuable. It actually will help you a lot later on in the process. So one of the things I'll go over quickly here is a little bit of terminology, and I put this in here only because there's a whole new set of terms that, if you're new to this, that predictive analytics has that most people will need to understand before they can go further in this space. So some of the things I list here are some of the things that are important to understand, but there's a lot more things out there to understand and a lot more terms. So I suggest that one of the things you do if you want to know more about this space is understand some of the terms that what people are talking about when they talk about this. For example, people may talk about the class variable. Well, the class variable is a variable typically what is the data we're predicting. So if I want to predict how much will a customer buy a particular product, yes or no, that would be the class variable, the yes or no. How much will they spend? What amount of dollars will they spend? That would be the class variable, the amount they spend. Will they churn? Will they cancel their service? That's the class variable, the churn variable. Scoring is the output of a model, the predicted values of the model. So again, another term important to know. Support is the number of instances of a particular pattern. How many instances in your data do you need for that pattern to be valid or to be valuable, to be something that you want to use? Because sometimes very few occurrences of something you want to ignore. So when you hear about support, that's what they're talking about. Overfitting and overtraining is actually a flaw in predictive modeling. It's often when we build a model that we think does really well, but in the real world won't perform well. That's because it reflects the data that we trained the model with too closely. So it can make poor predictions when we try to use make predictions with other data. One of the things we need for predictive modeling is historical data. If you want to predict how much somebody will spend with your company, you have to have some history of how much people have spent. If you want to predict whether people will leave your service, you have to have some history of people who have left your service and people who haven't left the service. So you need some history, and you need to make sure you have a history that you can use as a training data set, as a testing data set to validate the model. And but having a good set of history is one of the important things, at least starting off. Balancing a training data set is a way to ensure class values occur in a similar proportion. So that means that sometimes some data can occur very little in a training data set, and so by balancing it, we make it occur more often. So that way the algorithms don't get fooled, and they start predicting data. They start predicting things that we don't really care about because it's what occurs most in the data set. We really sometimes care about what occurs little in the data set. For example, churn is a good example. Most people don't churn, don't leave the service, but the few people that do are the people that we're interested in. Model disruption happens when an event occurs that causes a model to no longer make accurate predictions. So this is when models stop working. Let's say you're predicting whether somebody will leave your service or not, and now a new competitor shows up. That model may not predict very well anymore because the new competitor has changed things a lot. They're now maybe pulling customers that in the past wouldn't have left, and that will disrupt how well your models are predicting. And then there's a classification matrix or a confusion matrix. And it's a simple table that's easy to see and evaluate. How well is your model predicting? How many times did it predict something, and then how many times was that prediction the actual result? And then it's an easy thing to show to management as well, and show them how well your models may predict or may not predict. So how do we go about this? Well, let's say we're hiring somebody. I'm going to just do this exercise in my head here. But what data do I use? Well, when I'm hiring somebody, if I gathered all the data I could use about them, there's a lot of data about people out there. I might have a resume that has a lot of information. I may interview them, engage their personality type and their problem-solving ability. I might do an internet search on them and find out more about them. So in my head, I'm gathering a lot of information. I'm gathering information about how well they did at their university and maybe what certifications they have. I possibly give them some exams to determine how good their skills are. I interview them. So there's all this data that I'm gathering. So if I could take this data and put it in a database table, I may be able then to say, okay, now I can make predictions. Is somebody a good hire or a bad hire? Are they going to be a successful employee? So that's something that's difficult to do. And ultimately, what do? Well, do I make an offer or don't I make an offer to this person when I'm doing this? So I'm going to pull up an Excel spreadsheet here that shows this kind of in a simple example. What I've done here is I've taken data that I've gathered, and who knows where I've gotten this from. I may have gotten this from a database. I may have gotten this from some spreadsheets. But I've got I need some historical data. So what I've had to do is I've had to gauge whether people that I've hired in the past, were they successful or not. And then based on that, I determine here, are they successful in this area right here? And I say yes or no. And then based on all this other information over here, I would predict whether a potential employee is going to be a successful hire or not. So for example, in this case, I interviewed them and I scored their interview. I gauged their personality type. I gauged whether they were a leader or not. I gave them an exam and I scored the exam, and I determined whether they were certified or not. And just with those 5 pieces of data, I could build a predictive model that then tells me, are these people going to be successful hires or not? And yet it can be very complicated for us to keep all of this information in our head to determine whether somebody is going to be a successful hire or not. So this is the kind of thing predictive modeling can do for people. I could build a model, give it to my HR people, and they could execute it, and the model could help them make decisions about hiring people. Or I could give it to managers, and we could make decisions about hiring people. So in the end, that's what I want to do. I want to build a model that does that for me. So what I'm going to do here is I'm going to now build a model, and I'm going to build a model to predict churn. Now, churn is the term we use when when you lose a customer. So companies like cell phone companies and internet companies, they worry about churn because customers leave, and if they could stop those customers from leaving the service, they could save a lot of money or make a lot of extra revenue. So what I'm going to do here is I'm going to show how I predict churn using some of the tools like I'm going to use the Excel data mining add-in in this case. And what I'm going to do is I'm going to predict whether a customer is going to stay with me or leave. And really what I want to do is I want to predict, is a customer going to leave my service? So what I have here is an Excel spreadsheet with a lot of data about customers. I know their phone number, I know their area code and the state they live in, but I also know what plans they have. Do they have voicemail? Do they make international calls? I know how many minutes per day they use the phone, how many text messages they send, and so on and so on. I have a lot of information about them. And then in the end here, over at the right, on the right, I also know, are they going to churn or not? And if it's false, that means that customer did not churn. If it's true, that means that customer did churn. I also know how many calls they made to customer service. So I can use all that data to build a model then that predicts whether customers that I have now are likely to churn. So what I've done here is I have 3 data sets. One is a data set that has mostly customers that don't churn because very few customers do. So then I balance the data 50-50. Then I also have another data set here where I actually balanced it 30-70. So in this data set, 30% of the people churn and 70% of the people don't. So what I'm going to do is I'm going to use this data set to build a model. And some of you may have seen this before. This is the part that's been around for a while, but the point I want to make is most people either have these tools or own these tools. They own analysis services. They have Excel. They can download the data mining add-in. So it's something they could use. And you see here I have various things I can do. I can classify this data, which is what I want to do, to tell me whether I'm classifying a customer as a churn customer or not a churn customer. Are they somebody who's likely to leave my service or not likely to leave? So using that data, I'm going to predict, the column I want to predict is churn. And I want to predict whether that customer is likely to leave my service. So what I'm going to do here is I'm going to create the model with all the data in this data set. There's 1,000 rows in this data set because I've saved off another data set to test the model with. This is the way I build the model, but then later on I test the model with a different set of data. And then what I'm going to do is give this a name, and I'm going to call it churn for 24 hop in this case. And now that I hit finish here, the algorithm goes off and looks at this data and now starts building a model. And what it did here is it built a decision tree model for me. And using this model, I can now make predictions as to whether somebody is going to churn or not. So as you can see, it's very visual. Like a decision tree in this case shows me a lot about how it's going to process the data. And one of the things it's telling me is that the number of days per minute is an important factor in determining whether somebody leaves your service or not. So it splits that data into two, then it goes further down the tree, and then splits it more, and then ultimately makes a prediction. At the end of this, it says, okay, everybody who arrived at this point in the decision tree means that they are very, very likely to churn. All 31 people in my data set who arrived at that, who went down that path churned. So basically, if they made more than 242 minutes, or I'm sorry, less than 242 minutes a day in calls, they have an international plan, and they use in the international plan less than 12 minutes a day, and they make less than 3 calls a day. 100% of those people churned. So that's what these algorithms can do for you, and that's the kind of work, that's the kind of processing they do. So what I want to do now is test that model. Is it a good model or isn't it? Well, I can go here to my test data set, which I've set aside. I didn't use this data to train the model with, so the model didn't know anything about this data. And then what I'm going to do here is query the model. And by querying the model, what I'm going to do is I'm going to use the model that I just built, the one in 24 hop, the churn mining structure. And what I'm going to do is use my churn test data set. And in this way, it's asking me how do I want to line up the data in the table with the data in the data mining model, and it lines up well because I named the columns the same. And what I want to do in this case is, oops, I'm sorry, I shouldn't have hit that advanced button, so I'm going to go through that again. I'm going to use the same model, the same table, and then what I want to do is hit next here, and I want to add 2 output columns. And one of the output columns is the prediction. Will this customer churn or not? Give me a prediction, yes or no. I also want to add another column, which is the probability of that prediction. And by clicking on predict probability, oops, I'm going to get rid of that one because what I want to add is the probability of the probability that it is true that they will churn, because I want to know how likely they are to churn. And then when I hit next here and hit finish, this is going to append the prediction to the end of my data set. So if you look over here to the right, it added 2 columns here to my data set. This first column is the prediction itself. Is this customer likely to churn, yes or no? And then here is how likely, how probable are they to churn. So if you look down here, we predicted that this customer would churn, but he didn't churn. So that was a wrong prediction, and we were 90% sure that that customer would churn. We have another wrong prediction down here, but we were only 55% certain that that customer would churn. Now, here's a customer that we were 99.9% likely would churn, and that customer down here did churn. So that's very interesting to me because we made a prediction and we were very confident in that prediction, and the customer actually did churn. Now, if you notice the customer below that, also we predicted would churn, and they actually did churn as well, and we were 93% confident they would churn. Now, below that, down here, there was another accurate prediction, and we were only 55% certain they would churn. So you can see how this works. We make predictions, but we also say how likely that prediction is to happen. So this is one way to build predictive models. A second way, and the way of the future, is by using Azure and by using the machine learning tools in Azure. So this is, again, preview mode at the moment. So what I'm going to do is I'm going to go to Azure Studio, Azure ML Studio, by following this link. And I'm going to log in to Azure. And right now it's free because it's in preview mode. In the future, there's a charge for it that you can see how much it will cost you to do this. But basically what in Azure what you can do is you can set up experiments, and these experiments are models that you can build. And oops, I need to get rid of the feedback screen here. And you can build models in a drag and drop sort of fashion, and use a lot more algorithms and more tools than we have available to us in the analysis services data mining tools. So for example, if I want to build a new, what I've done here is the churn data that I just used in Excel, I also uploaded it here to the so I can use these data sets and build these models here as well. Now in the preview mode, Microsoft provides a bunch of data sets that are data sets you can use to play with. But you can also upload your own data, or even point this to maybe your Azure data set or your Azure database or Hadoop, your HD Insight data, and start building models with that data as well. So what I'm going to do here is I'm going to build what's called a new experiment. And that new experiment is a way to do what I did in Excel. I'm going to build a data mining or a predictive model for that data set. I'm going to predict the chances of somebody churning. So what I've done is I've uploaded my churn data set here to this tool set, and I'm going to use that data set to start with. And by dragging it over, it says, okay, that's going to be an input data set. As you can see, this is somewhat of a, if you're familiar with ETL and SSIS, this is something of an ETL style data flow here. One thing that I can do here is I can also give this a title. I'm going to call this churn for 24 hours of pass. And what I'm going to do is use as a starting point the data set to train with. And then what I do is I go down to the machine learning section here. Now there's a lot of other sections here. This is a big tool set, and I'm not going to show everything, but I can convert the data. I can transform the data by filtering it, manipulating it, splitting it. I can also invoke feature selection. So I'm not going to do most of that at this point because it would take a whole session to do that, but I'll do more of that in the pre-con certainly. And so the first thing I want to do with my data is I want to train the data. So I'm going to go here to the machine learning section, and under the training section menu item, I'm going to select train the model. And so I'm going to drag that over here. And what I'm going to do then is connect the two data sets. Or not the two data sets, but I'm going to connect my data set to the train the model task. And as you notice here, I'm not really finished yet because I don't know how I'm training the data set. So what I'm going to do is I'm going to first select the column that I want to predict. So what I'm going to do is I'm going to predict the churn column, just like I did in Excel. And I'm going to hit OK here and hit the check mark. And then what I want to do is tell it what type of algorithm I want to use to do this training with. So I'm going to go back over to initialize model, and you'll see an initialize model that I have all the algorithms that are available to me. I can use classification, I can use clustering, I can do regression. So in this case, I'm going to classify the data because I'm going to classify it as a churn true or churn false. And so I'm really just doing two types of classification. So what I'm going to do here is use a two-class neural network, and that will allow me to predict whether they yes will churn or no they won't churn. And then I'm going to connect that to my training model process. So then now, as you can see, what I'm doing is I'm building a process where the data will flow from my churn data set into the training model task, and it'll process it as a neural network in this case. Next thing I want to do is score the model. So I'm going to go back. Oops, let me get rid of that. I'm going to go back and pick under the scoring menu item, score model, and I'm going to drag that over. So now this is where I've trained the model. Now I want to test the model. So this is where I'm going to apply the model to a test data set and see how good that model actually performs. So what I've done here is I've also got my churn test data set uploaded, and so I'm going to pull that over, and it's in this CSV file. And by using that data set is set aside, So it's not part of the training, but now I can use it to evaluate my model and validate how good it is. So I'm going to pull that over and drag it over to scoring the model, and I'm going to have the output of the training go into scoring the model. So now I'm using the model that I've trained, and now I'm going to apply that model to my test data set, and that's going to then tell me how good of a model I have. Do I have a model that's predicting, making good predictions or not? So, so what I need to do then is evaluate that. So I go back to the machine learning menu item to evaluate, and I'm going to say evaluate model, and drag my results into that process. So now what I've done is I've basically done the same thing I did in Excel a little while ago. I'm building a model, and I'm testing that model, and then I want to see the results. What will be quite different here is how the results are viewed. So what I do is I go back down here and save the model, and I'm going to run the model. And when I run the model, it looks like SSIS a little bit. If you're familiar with SSIS, you'll see check marks next to the model as it goes through the process, and you see now that I've got check marks at the end, and it's finished. So what did it do? Well, I need to now see the results of this process, and I right-click on the Evaluate Model, and I can visualize the results of my process. And by visualizing it, it's going to show me a curve, and it's going to give me a lot of data about how good it's making, how well it's doing at making predictions. So in this case, I can't go through this in a lot of detail because we just don't have a lot of time. But you can see a confusion matrix down here that it's telling me how well it actually predicted, how many were true, how many it predicted true that were positive, how many it predicted false that were negative, how many it predicted false that were positive, and how many it predicted true that were negative. You know that so you can kind of see how well you're doing, how poorly you're doing. You know, if the model's not doing well, yeah, you'll get a clear picture of that right there. One of the things that you can see here is the probability as well. And if you look down at this chart, you see that there's a probability of prediction here. So when it scored the model, it said the ones in this first row, it said those were 90 to 100% likely to churn in this case, and there were 44 in that category, and 38 it predicted correctly that did churn. So you can see that by how you can use the probability of the prediction like we did in the Excel spreadsheet, you can also determine how good the results you're going to get. So for example, the ones that as we go down further, we see that our results get worse. So what I could say to management is I could say anybody that I think is 90% likely to churn is very likely to churn. It seems like that they would be at least 80 to 85% likely to churn based on our model that we're using to predict. Now, one of the things I want to say is I know that I just covered this tool very quickly. There's a lot more here, and there's a lot more to see. For example, one of the things I can do while I finish up here is I built a model earlier where I can compare I can compare models. So this model, what it did is it built two models at the same time with the same data. One used a support vector machine, one used a decision forest. And what I can do now when I evaluate the model is compare the results of the two. So you can see my curves. You can see that the model that I scored is the blue model. That was the support vector machine. And then the one I compared it with is the one in red. And you can see that the one in red performs better than the one in blue. So the decision forest in this case performed better than the support vector machine. And so it allows you to do things like this to compare two models using the same data to see which model you're getting better results with. And so there's a lot more here. So I suggest if you're interested in where this is headed, and I think the future of predictive modeling with the Microsoft tools, this is where you should be looking. And so what I'm going to do now is I'm going to go back to my PowerPoint, Sorry about that. It kept asking me about my color scheme, so I finally decided to hit OK on that. Oh, I'm going to go back to my slide deck here. Sorry about that, and just finish the presentation, and then hand it back to Martin for any questions. So what I did here in the last 2 slides is I just laid out the steps I took to build the models with Excel, and then I also laid out the steps here of how I built the models with Azure, and then I also listed the URL there. So if you're interested in going and using those models as well, you can do it yourself as well. And then what you can do with Azure is you can once you've built a model and you want to implement it, you can also invoke a web service that then allows you to use that model and call that web service from code that you've written. So the model will be useful through, even though it's in the cloud, it will allow you to access it through the web service in the cloud. So that's very interesting as well. So, we're kind of near the end of our time here, so I wanted to hand it back to Martin. Any questions? Anything I should know, Martin?
There was one earlier on, just a general question. Is the session being recorded, and we'll get a recording of the demo from Forrest Wyman. And yes, the whole session is recorded as you've seen it on screen, so you will be able to follow the whole process through that way if you look onto the site later on. And another question from Suhail Mangera. And I don't know whether you'll be able to answer this one, Carlos. It's more around when will Azure Machine Learning be available in the APAC region, and is there a way to use it from New Zealand right now?
And I don't have a good answer for that. I don't have any inside information as to when things like that might be released in certain places.
Yeah, I don't have anything else I can really add on that myself, other than I know that the Azure data centers in Australia will be online later this year. It may well be that more of the Azure services spread out through the APAC region as a result of that, so that's a possibility that way. We have another question from Rajesh Babu. Any use cases for DBAs related to monitoring? How can machine learning, predictive analytics help DBAs for internal consumption? That's a very good question.
Yeah, it is, and and I think that's a great use case. I haven't actually had to deal with that in a real project, but I've always thought that would be you could take so much data that you gather from your databases, from your monitoring systems, and then you could build models that maybe tell you ahead of time, when you might have problems, when things might start going south, for example. And I think that's a great use case that if somebody wanted to take that on, I wouldn't mind helping them or working with them on it, because I think there's a lot that can be done there.
So probably a recommendation for Rajesh to maybe ping you directly.
Yeah, that would be fine.
If you want to go through that conversation with him there, you might get some more information that way.
That's exactly true. I mean, if he would like to talk more about that just personally with me, or have an email conversation or something like that, feel free to use my email and contact me.
And another one from Alan Smith, mentioning that your slide deck has a few that weren't in the PDF download version. Will that get updated?
Yes, I actually, as usual, I was making changes to the slide deck 10 minutes before the presentation, so I sent that off to the people at PASS, and they should be uploading it. They may have uploaded it already by now, so hopefully you can download the slide deck and get what I showed, actually. So that was only done maybe 10 minutes before the session.
Yeah, and failing that, Alan, obviously you can review the session itself, and you'll still have access to what was on the slides there. But hopefully we should be able to get that updated as well. And Nick Aubrey has come up with an absolutely fantastic one. How about using predictive analytics to predict horse racing results based on past data? Yeah,
so I hate to admit it, but I've done that before, and I don't want to demo it, but I think it's, again, first of all, it's a great way to learn about it, right? If you can set up a predictive model and predictive analytics to predict horse races, you could do a lot of other things as well, right? So it would be a great way to learn the tool set, learn how to use the data, and how to set up successful models. And then also, it can be very interesting to do. So very, something. I think it's a good topic, certainly.
I'm guessing it's not absolutely perfect. Otherwise, you wouldn't still be working. You'd be sitting, sunning yourself on a beach somewhere.
Yeah, that's right. Well, there are reasons it's difficult, right? Yeah.
It'd never be exact. That looks like all the questions. Anyone else has got anything? No, looks like we're probably done on the questions. So moving on from there, if you've liked what you've heard here about the predictive analytics, Carlos will be presenting at PASS Summit 2014. He'll have a general session on Get to Know HD Insight and Start Mining Big Data, and also the full presentation of this pre-conference session, Predictive Analytics in the Enterprise, at PASS Summit 2014. Don't forget to use the discount code 24HOP14 and save $200 on your PASS Summit registration. We've got a couple of thanks coming in, and rather than just general questions, just a bit of feedback for you there, Carlos, that a few people are obviously showing their appreciation on that one.
Well, thank you very much. I appreciate that.
Stay tuned for our next session, which is managing both on-prem and Azure databases with PowerShell with Alan White, which will be happening in a couple of minutes. And thanks to everybody for their attendance here and to Carlos for his presentation.
And thank you very much for hosting, Martin.
No problem. Thank you.